All right, so we're getting ready for a test on Thursday. The test covers sections 5.1 to 5.4. So we've got a review in my math lab that you're working out. And then I also printed out a page out of the textbook, page 598, that had this material covering sections 5.1 to 5.4. So I thought I'd do some review videos, and I'm going to use the problems from page 598 for the video. But join me for some help sessions if you want to go over any of the questions out of my math lab assignment. I'd be happy to do that as well. I may create a video on maybe the application problems out of there just to help you. But anyway, so before I get started, you might want to go print that page 598 that I posted and have that ready. So let's go ahead and get started. I'm going to do a couple problems out of there, out of the early material. So like problem number 2 was giving you something in degrees, and it said to convert that to radians. So you were going from degrees here, and it asked you to put it into radians, and it said to express it as a multiple of pi. So you want it in terms of pi when you're finished, okay? All right, so one of the things we know is that pi radians is the same as 180 degrees. And so that allows us to write a unit fraction, and then we can use that to change the units. And so this process right here is using unit analysis or dimensional analysis. So it's a real handy little technique to do. So I'm going to leave pi on top, put my degrees on the bottom so that the degrees will cancel. And then I'm just going to divide. So I notice that both of these are divisible by 5. So sometimes when I'm not using a calculator, I like to just do whatever I see and notice first. So I notice 5 goes into 18. It will go in there 36 times. All right, so at that point, I'm down to negative 21 pi over 36. But now I notice the 21 and the 36 are both divisible by 3. So I'm going to divide them both by 3, and I'll wind up with negative 7 pi over 12. And they want it in terms of pi. So you leave it right there. And that would be your answer to number 2. Okay. All right, the third problem was the other way around. So on that one, they gave you 5 pi over 12, which was in radians since it didn't have the degree symbol on it. Plus it said to go from radians to degrees. Okay. And I'm going to use unit fractions, but this time, since I want to get rid of the radians and get degrees into the mix, I want degrees on top, radians on the bottom. Okay. All right, so I can see how the pi's are going to cancel. And then when I'm looking at 12 into 180, if I don't have my calculator, I can't really tell what that's ultimately going to be. So I might just notice that, say, 3 goes into both. I could tell that. So 3 goes into 12 4 times. 3 goes into there 60 times. Okay, now I can see that 4 would go into 60 completely and leave me just 15. Okay, so I have a 5 from here and a 15 from here. So I'm going to wind up with 5 times 15, which is 75 degrees. Of course, you could type in the 5 times the 180 divided by 12 and let your calculator do that as well. All right, so that's all they wanted on that one. All right, now the next group of problems. So when you're looking at question number 5, 6, and 7, that one says to find an angle that is coterminal within one rotation. Okay, so find a coterminal angle. I'm writing it a little different. You should read it on the sheet because you're supposed to have printed that, and then you can see how they expressed it. I'm just kind of shortening it a little bit. Find a coterminal angle within one rotation. So if it were degrees, it'd be less than 360. If it were radians, you'd want it less than 2 pi. Okay, that's part A. Okay, next thing they want us to do is to draw it in standard position. I do that to start with. Okay. And I would draw the given angle, the original angle in standard position. And then the third part is to find the reference angle. Okay, so I kind of like the way they did this, where they put all that together. Let's do a couple of these. All right, so let's look at question number, let's do all of these, okay? So number 5 was 11 pi over 3. All right, so I like to draw first, so I'm going to do that first. Okay, so when it has a denominator of 3, you should be thinking about breaking pi into 3 pieces and then continuing that on the bottom side. So you can kind of count around and also think about how that would be, 1, 2, 3 pi over 3 here. And then this is 4, 5, 6 pi over 3 when you get around to here. And so you have to keep going. 6, that would be 7 to 8 to 9 to 10. This would be 11 pi over 3. I also know that because it's just one more pi over 3 away from hitting this all the way around a second time, right? So 2 pi was 1 rotation. 4 pi would be, this is 2 pi. 4 pi would be 2 rotations. So that's another way to locate it. So this would be your angle. Now, when you draw that, you really should show me the rotation. So you went around one whole time and then around again until you wound up right there. So that would be the picture of the angle in standard position. If you don't draw the whole rotation, you won't get credit. Also, I want to see your thinking. How did you know to get there? I don't really want you changing to degrees. I want you thinking in radians on this, okay? Now, the reference angle is this angle right here, okay? So if this is your theta, then this right here would be your theta prime. So if this we call theta, this would be the reference angle, the theta prime. So theta prime would be the difference between where you are and getting all the way to the x-axis. So see how you're 1 pi over 3 away? Your reference angle is pi over 3. Now remember the importance of that, okay? Okay, so the importance of that, the pi over 3 and 11 pi over 3 will have the same trig function values, except for you might need a negative sometimes, okay? All right, so this is the reference angle. The reference angle and the original angle will have the same trig function values. It's just that you might need to throw a negative on them depending upon the quadrant your actual angle is in, okay? All right, now one other piece of this, so this right here is the reference angle. The other piece of this is they wanted me to express the angle, given an angle that's coterminal to it, okay, same exact terminal side, that's within 1 rotation. So it's like that 11 pi over 3 right there, if I took away 1 rotation, okay, which would be 2 pi or 6 pi over 3. See how I'd have 5 pi over 3? All right, now 5 pi over 3 and 11 pi over 3, these are coterminal. Okay, coterminal angles have the same exact trig function values. Same exact ones, sine and everything. Sine and all. Sine and all. Okay, the reference angle and the original angle has the same, how do I word it? It's the same trig function values, except you have to consider the sign of the original. You may need to throw a negative on there. Okay, so it's like it has the same number parts. Might be an easier way, same number parts. The trig function value will have the same number parts, but you might need to throw a negative on some of them. And that's going to happen. We're going to have to do that a little bit later. Okay, let me see if I can space down. All right, so now let's look at number 6. Number 6 was the angle negative, still with a pi, negative 19 pi over 4. So since it was over 4, I'm splitting up pi into 4 pieces. I'm going to do that all the way around. Negative means I'm going to go clockwise. So that would be 8 pi over 4, wouldn't it? 2 pi would be 8 pi over 4. Okay, so I can go around a whole nother time, can't I? I'd be at 16 pi over 4, and then that would be 17, 18, 19. Okay, so right here would be where negative 19 pi over 4 would be located. All right, so if you're trying to do this one, you might be able to just look at that picture and think about where you are, or you could think to yourself, I need to get to have a positive angle within one full rotation. So you can adjust this by like adding multiples of pi to this, like add 2 pi, okay, that'll get you to negative 11 pi. Add another 2 pi, you're still in the negative though, that would be negative 3 pi over 4, okay. All right, let me not put equal signs. Okay, let me change the size of my eraser a little bit, I got it too big. Okay. All right, so that one's a negative 11 pi over 4. And then if I did a negative 11 pi over 4 plus 8 pi over 4, I'd be at negative 3 pi over 4. So if I added another rotation, that would get me to 5 pi over 4. All right, so that's one way to do it that you oftentimes see, is that you can keep adding, you know, a full rotation, in this case 2 pi, but since the denominator was 4, I used 8 pi over 4, and just keep adding those rotations until you get into a positive area. Other thing is you could just look at this, since you've graphed it, that's why I like to graph it first, and you could see that this angle right here within one rotation would be 1, 2, 3, 4, and I can just see that it's 5 pi over 4 because I can count it going in the positive direction. Okay, so 5 pi over 4 is a coterminal angle within one rotation. So that means these two would have the same exact sine, cosine, tangent, including the positives and negatives. All right, now let me change to blue. The reference angle would be this guy. It would be the amount of rotation between the x-axis and the terminal side of your angle. Okay, so that would be the reference angle would be pi over 4. Okay, so the reference angle and the original angle do not have the same exact trig function values. They have the same number part though, and then you'll just need to put a negative sometimes, depending upon whether your sine, cosine, or tangent is negative when you're in this quadrant. Okay. All right, so this question said to find a positive angle that is coterminal with the given angle. That's the 5 pi over 4. It said to draw the given angle in standard position. You should show in what I did in black, that rotation going in the negative direction around twice before it got there. And then find the reference angle would be what I did in blue, that little space between the terminal side and the x-axis. Okay. All right, I think I'll go ahead, and I like to keep my videos kind of short so it's easy for y'all to load them and watch them. So let me stop this, and then let me think about which ones I'll do together. I think I'll do 8, 9, and 10 in the next video. So let me go